we're going to investigate heat energy. And we're going to shake a sealed container containing sand and let the motion heat the sand. We're going to be converting kinetic energy into heat energy. Safety precautions, and pause to reread. Care as you're shaking the sand. Care with the glassware, thermometer, or electricity if you're using a digital thermometer, and wear goggles. The materials you're going to use: screw top container, some sand, electronic balance, thermometer, and a timer. And what you're going to do is mass some sand and shake it for a fixed amount of time. And the shaking will involve kinetic energy. You're moving. And the temperature change will be involving heat energy. So you're going to mass an empty container with a screw top lid. Mass the container with approximately 350 grams of sand. Know its exact weight, and you'll actually be using kilograms in your calculation. Take the initial temperature of the sand, shake it for 10 minutes, and immediately at the end of the 10 minutes, take the final temperature. So you're going to process the data. You're going to find the mass of the sand and its temperature change, and then you're going to calculate the heat energy produced by the shaking. But you'll need to know the specific heat capacity of sand. So here are some experimenters massing an empty container, taking the temperature of the sand, having massed it, and we're going to look at your physical work, movement, producing heat energy. The sand will be shaken very vigorously to just go into the video.
It's supposed to be around 53.13 and then the uncertainty 0.0.
Wait, so mass of the cup. Oh, wait.
Yeah. It's close to time.
Oh, you're doing it for 10 minutes straight? Yeah.
19 Celsius.
And then in Kelvin, it's
Plus or minus. Yeah, it's supposed to be.
No, let's see who's got the best temperature rise. Go.
That's actually kind of solid. Wait, gotta end it real quick. Take fast, graduation. Come on, guys, sprint this last one. 5, 4, 3, 2, 1. Seconds, Jasper, go. Do this. Do it. No, that's doing. No. Oh my God. I can't see it. Oh, it's slow.
Yeah.
All right, there we go.
You got it.
You lost.
You lost?
I did.
Don't let it touch the bottom.
No, that's good. Are we going to
It's still going.
Yes, it's rising.
It's still going.
It's rising.
Rise, my friend.
Rising sun, you know. House of the Rising Sun.
It's rising, yes.
House of the Rising Sun.
Yes.
So does it keep going?
Yeah.
What's it at now?
26.
hardwood cracker?
And then we're going to calculate the heat energy generated during this experiment with the data that you have collected. We'll use the specific heat capacity equation, where heat energy is the mass of the material that you're dealing with, C, the specific heat capacity, and delta T, the temperature change in Kelvin. Numerically, it's exactly the same as the Celsius change. And we're going to use a specific heat capacity of sand here. And if you look up the data, different types of sand, quartz sand, clay sands, and in between sands will have different values. So again, some more experimentation. You can do your calculation. And if you haven't collected data or need more practice, here are 3 different trials with their data, and you can pause to download the actual measurements that were taken to calculate the energy involved in the transition. And here's trial number 2 for data, again, if you need to do some experimentation. And the 3rd trial here, you can get off a student's data sheet here. So where does the heat energy come from? And you're going to solidify your knowledge by describing how you calculate energy change when sand warms up as you shake it. Where does the heat come from? We've got friction here. And why does friction generate heat energy? And many thanks to WIS Science for use of their lab and the students' involvement in the experiment.